Hi, hi everyone. Thank you for joining us today in this session. My name is Dani Almeida. I am the founding member of the AI Guild and the Data Lift Director. Welcome to all of us that are now live. And if you are watching live, please be active and type in your questions on the chat because then we can answer them now. So today with me, I have the guest Nava Levy. Nava is a developer advocate for data science and MLOps at Redis. She started her career in tech with an R&D unit in the IDF and later had the good fortune to work with and champion cloud, big data, and deep learning, machine learning, and AI technologies, just as the wave of each of these was starting. Thank you for joining us live today, Nava.
Thank you for having me. I'm very excited to be here, and I'm really looking forward to the summit in June in Berlin and meeting everyone in person. Really looking
Yes.
forward to it.
Same here, same here. So yes, the reason why we are talking today is because you will be coming to Berlin in June to have a keynote. And just before we get started in the topic of your keynote, I would like to ask you to do some introduction about your career. So if you share with us how you got interested in the topic of AI and deep learning.
Sure, I'll be happy. I think it was back in early 2015, the end of 2014, so many years ago. I was a strategic planner, doing strategic planning for cloud and big data at Intel. And I
Mhm.
was looking at workloads that it was challenging for them to move to the cloud or were just starting to move to the cloud. And one of them was cloud gaming. And the reason it was pretty challenging, but the main reason was latency. So as I was investigating this workload, I quickly saw that one of the leaders in the domain was a company named NVIDIA. So I started, looking at NVIDIA and checking, see what they are doing and stuff. And it was fascinating what they were doing in gaming. But even more fascinating, what were they were doing in supercomputing and what they called deep learning. Now I didn't know what deep learning is. I had no idea. But the more I looked at it and investigated and researched, the more intriguing, it was for me. And to the point that when I heard there was a GTC, NVIDIA GPU Tech Conference in San Jose, I just, jumped on the plane and went to see it for myself, to see how, and I was completely blown away. I saw, one cloud vendor after another, if it was Google or Facebook or Salesforce.com, showing the researchers, showing how they are beating SOTA, how sometimes they are reaching human level performance in tasks like NLP and computer vision. And at that time, it was remarkable, especially for someone who wasn't. It's not like I was 10 years in the academy and I watched it. And and what happened was it was the machine learning started in the 60s. Even deep learning wasn't that new, but something happened. Something caused an inflection point. Same as 10 years earlier, something caused an inflection point in cloud computing, and and I knew that this is going to change the world as it is. And since then, I really tried to stay very close to the domain of deep learning, machine learning, AI, to deal with it when I'm working, when I mentor startups, when I'm learning online courses, up to the point that I joined Redis, and I'm doing this full time, dealing with machine learning and AI on a full, 100%, and I couldn't be happier.
Yes, great. I mean, it sounds very exciting also to be there just at from the beginning and being able to experience this inflection point. Can you
Yes.
tell us a little bit more about what is your role as Regis?
Yes, so at Redis, I'm technology advocate, developer advocate for machine learning and AI, or data science and machine learning operations. So we are a group of technologists and who love technology and love to educate. And this is basically what I do. I deal with anything to do with data science, artificial intelligence, machine learning, deep learning at Redis.
Great. And or maybe we in our audience have already seen you with the AI Guild, we first met each other when you were presenting one use case at the Data Leap number 7, which was this year back in February. And there you were talking about the role of feature stores in deploying real-time AI. So then your topic was really focused on feature stores. You have also been doing other talks in other events about feature stores. And now we are talking, or the topic that you're going to bring to the summit is about the embeddings, so vector embeddings and the paradigm shift. Can you tell us maybe what those two topics have in common or how they become different topics? Please expand on this.
Sure, sure. So maybe just a step back. Redis, for people who are not familiar with Redis, so Redis
Sure.
is a super fast in-memory database or a key value where the value can be any data structure, and it's used for real-time applications like leaderboards and inventory management and anything that you need a super fast database. It's also used for any application as a cache to make it much faster and much more cost effective. And that basically for any application that is interactive. And I think we don't know any application that isn't interactive. So basically, real time means interactive, and when you need Redis is when you have high throughput. Okay, so usually even with a disk-based, a slow-based database, you can achieve, not the best latency, but pretty well if you don't have many users. But once you reach a certain throughput or scale, then it becomes very costly to keep the latency in performance that the user experience is still good. And I actually experience this myself. Other than being a developer advocate at Redis, I'm also a founder of an EdTech venture, LerGO. I don't know if I mentioned this specific case, but when COVID hit, we had a huge spike, more than 10x usage
Wow.
spike, and it made LerGO slow. So it didn't crash, but it was slow, and people expect interactivity and not wait even a second. They need 200 millisecond, 100 millisecond, and we did a performance testing to look for the bottlenecks, and we saw that we have a bottleneck, which is the MongoDB database.
Okay.
And after investigation, we realized, and we could have solved the bottleneck by basically increasing the cost 10 times. So instead of having one instance, we would have 10 instances, and that would have solved it. But we found a better way to do it. We added Redis as cache in front of Mongo, and we didn't reduce the cost at all, and we tripled or quadrupled the capacity, and that was amazing, and we did it within days. And lots of teachers and students are still very thankful to that day, because this was just as we had the lockdown, and they really needed LerGO because it's an e-learning platform, and they all went to remote learning. And we were very
Yeah.
thankful for Redis. I wasn't working at Redis at that time, so I'm a huge fan of Redis, so that's why I'm also
Interesting.
now a developer advocate for Redis. So anyway, so this is Redis. Now, real-time AI-based use cases are no different. They also need a fast database or a fast cache, depending on the use case. And so anything that in machine learning needs a real-time, or super fast database, then this is where Redis plays. So in the online feature store case, or feature store for real-time AI, this is a classic use case for Redis for machine learning, and it was adopted by the community. Redis is open source, so the community basically found that Redis is the most suitable for to be an online feature store for many reasons. And then once we saw that, we added improvements and made it even better and better. But it's not that we thought, we think that Redis could be great for online feature store. Let's convince anyone. It was actually the community it told us that Redis is great. It's the best online feature store for companies who have real-time applications or real-time based AI. And I don't think there is a single company, today that is, let's say, more than a very, very small startup that doesn't have real-time AI. If they have AI, if they are not yet, they don't have AI, that's different.
Sure.
Yeah, but if they are doing machine learning, it's not like 5 years ago that most of the machine learning and AI was batch predictions, and maybe once every 24 hours, maybe one every 5 hours, one. But today everything is moving to real time, and this is where an online feature store is key. Otherwise, you have a bottleneck, and you really can't deploy machine learning to production without that. So that's feature stores. Um, Embeddings are, it's a different topic. It's a very exciting topic, something I've been following for years. It's one of the byproducts, if you will, of deep learning, right?
Yeah.
And one of the most amazing byproducts. And embeddings, those dense learned vector representations that imbue the meaning, on the fundamental level, the actual context, the semantic meaning of an object, any object, whether it's a document or whether it's a video or an image, and basically any modality, text, image, video, audio, time series, DNA, you name it, can be an embedding can be generated. And once you have the embeddings, then the opportunities are endless. And we see embeddings in the training pipeline. Okay, so that's, let's say, one use case for embedding.
Okay.
And we see embeddings also in production for semantic search or neural search or vector similarity search. And if we're talking about embeddings in the context of training pipeline, it's very exciting. I think that it basically enables, if we look at deep learning, and I'm in awe of deep learning ever since I've been at GTC back in 2015. Then there is one problem, or few problems with deep learning, is that not all companies have the teams of hundreds of people, of teams experts in data science and machine learning, and not all companies have the budget for the computing to compute, for to do the training for those huge neural networks. And just as an example, GPT-3, it was $10 million, to train once. And let's say they want to refresh the model every year or every
Yeah.
quarter, who has $10 million? And not every company has access to the data sets, that deep learning needs. So what are we talking about? Half a trillion words for GPT-3, or even if it's just billions of words, it's like BERT. It's unthinkable. It's something that Facebook, Google, can afford, but the rest of the companies can't, and that's pretty bad. And coming from LerGO, which is a venture that is designed to bridge the social gap in education in Israel. So I'm always, when I see something like this, on the one hand, I'm very excited, deep learning, wow, it's mind-blowing,
Yeah.
it's changing the world, but I don't like it that it's only a few companies can enjoy it. So embeddings is one way that we see that anyone can touch deep learning. It's like, the power of deep learning in the palm of your hand, right? So it's democratizing deep learning, and it's very exciting. The applications are amazing. And this in the all the companies and the ecosystems and open source frameworks, all of it, if it's Kaggle, if it's Hugging Face, all of this around it is really exciting. Um, and on the other hand, there is also performing vector similarity search in production. Now, both use embeddings, but
Okay.
the challenges are completely different. So if for training, even if they both have, let's say, a million embeddings, let's say both use millions embeddings, when you do training, you don't want to do it on months or weeks. You want to do it, let's say, on hours. You still have hours, but when you do vector similarity search for real-time use cases, and as we just said, now every use case is real-time. You have to do it in a split second, and
Yes.
to do that, on a scale of millions embeddings, and even sometimes billions of embedding, it's a shift, right? It requires a new type of technology. Sometimes it's called the vector database. So you will see, if you Google vector database, you'll see that there are many startups all saw the opportunity and are trying to go after this opportunity of vector databases. But then
Hmm.
we have the challenge that vector databases is just one more database. So what, we're going to have a graph database and vector database and time series database and JSON document database. Doesn't It's really adds to complexity and cost and the technical depth. You're going to have expert in every stack, and the integration. It's really a problem. So the vision that with Redis that we see for vector similarity search and vector database is to do what we did with all those other databases that I mentioned: time series, graph, document. So we're all the time adding new data structure. So by adding JSON data structure, we are basically supporting a document database like MongoDB, but just much faster. Okay, instead of slow disk-based, it's much faster. And the same goes for graph and for time series and for vector databases. And the applications I don't want to say all the things I'm going to say in the presentation, so wait
Yes.
for the talk, there are far-reaching implications to all of this, and how to do it, and what are the challenges and what are implications and what is missing to do it right, and so forth.
Yes, it sounds like you are at the edge of this technology, and by joining your keynote here in the Data Lift Summit in Berlin, people can really get it directly from the source, from you, and of course have the chance to meet you in person and have other discussions that can go deeper into this. Um, I am thinking, so let's not talk so much about the concept and the technology development itself, but maybe we can also talk a bit more about the different use cases that we see. So if we think about business use cases for using embeddings, can you share a bit with us what you have seen already? What kind of industries are using it, or what kind of business challenges are being solved with embeddings, both for
Okay.
model training or for search?
Okay. Cool. That's a great question. Okay, so let's think first of for model training. Okay, so let's say we have we used an embeddings, let's say BERT, for NLP, and now we want to apply it to a semantic use case. To that not sentiment use
Okay.
case. So let's say I have a community and there are comments, and I would like to know what the sentiment of the comments, and if there are, let's say, comments that are toxic, I want them to be removed. So, and let's say my community is very specific. Maybe it's in the area of medical, maybe it's in a very specific area. So I'm using the BERT that was trained, on corpus, a very large data set, to generate the embedding, and then I'm doing fine tuning to the downstream machine learning model fine tuning for my use case, the sentiment analysis. And this way I'm doing transfer learning. The data set that I'm training, the downstream model, is
Mhm.
doesn't it's not as huge as it's maybe it's 1%, maybe less than 1% of the data set that was used to train BERT. But I'm basically leveraging those embeddings, and with really just a small number of labeled data set, I can reach a very good performance for semantic, not semantic, sentiment. I'm doing it again for sentiment analysis, and that's huge. Imagine that I didn't have what I had to do before there was embeddings. It basically would have been out of my reach. I wouldn't be. Maybe I would do it rule based, but we know that rule based or other techniques are much less effective. So to reach very high accuracy, but without incurring the cost of training a huge neural network, and really, frankly, it's not possible to have so much comments on my little community, in medical community, whatever, then I wouldn't be able to implement this use case. So this is like one example from the training, and you can see how it's democratized. Now, one of the things that
Right.
enabled embeddings is not just deep learning. Deep learning, started, but deep learning had lots and lots and lots of evolutions. But it's without self-supervised learning, embeddings the way they are today wouldn't have been possible. So it's like, I think Jan LeCun calls it the dark matter, of machine learning. It's so huge, because like when we trained back in 2015 to get to beat SOTA, face recognition, and we had data sets of 5 million, 6 million, Facebook people, Facebook users uploading pictures, or 10 million, but it wasn't huge data sets. To get to the level that the neural networks are today, you have much like 100x data sets, and also the neural
Yeah.
networks are 100x or 1000x larger. And how is it possible? What we don't have those trained label sets. The way it's possible that the machine learning community found a technique to train those enormous neural networks by implementing self-supervision, by artificially creating those supervised training sets, pairs. And this is really one of the huge things that enable. There were other things like attention mechanism that, from word to vec to BERT, that gives the context and allows to train much faster. So not only can we perform such training, we can also do it much faster. So there were lots of other
Yeah.
breakthroughs, but all of them are building on one another, and now everyone can use it. Also small companies that don't have those resources have the power of the sun at the tip of your hand. So it's really really amazing. So this is training, okay? And now for vector similarity search. So again, like in training, there are many use cases, many verticals. I
Mhm.
think there isn't a vertical that can't leverage or isn't leveraging yet. So I think the same is true for vector similarity search. Um, let's say recommendation. Okay, so if you are a user, and I want to offer you the best articles or the best products, and I know that you have a problem, not you specifically, a problem with attention. So I want to only show you the top three. Okay, so it's KNN, the top K, or if it's a question, a completely different use case, questions and answers use case. So if I find the question, let's say I write a question in a question and answer system, for support. Let's say I write a question, and now in the background there is a vector similarity search to see which question is most similar. Okay, then I can show you the answer to the question that is most similar, right? So this is like say what's the relations between vector similarity search and questions and answers. So the relationship that is that we look at, maybe we have 1,000 question and answer in my support system, for the community that I just told you of with the
Yeah.
comments, right? Yeah, and this way, the vector, my application can really quickly find the right answer to the questions, and it could be reverse image search. Let's say I like this shirt, but I couldn't find it in any store, so I take a picture of
Mhm.
it and then I upload it and I say I want to find a shirt similar to this. So again, let's say I have a catalog of 10,000 shirts, and I can do this, comparison. Maybe it's a million, maybe I'm Amazon and it's a million, and I can do this in a split second. Why does it have to be in a split second? Because, as we said, not you specifically, you don't have a lot of attention, right? And you're not just going to wait, a few seconds for it to fetch, right? You
Yes.
want instant gratification, instant experience, and you don't want to know that maybe there was a fraud detection process in the background. So again, fraud detection is traditionally implemented in machine learning in the training pipeline, but now with vector similarity search, we can maybe in certain use cases identify transactions that are fraudulent because they are similar to other transactions that they are fraudulent, and spam filtering. So it's basically for any modality, if it's text or audio or video or images or time series and there are so many applications. I'm very excited to see it. Every time it blows my mind when I see another cool use case and stuff.
Yes, exactly. Like you just shared a little bit, and we can see that there are a lot different use cases. We can be creative how to use embeddings for either model training or for the vector similarity search for real time queries. And this is, I would say, this is like you mentioned, maybe in every industry it's possible to find a use case. It's really nice.
Yeah.
Thank you, Nava. I think we are reaching now the end of our session. We didn't have any questions from the audience, but we do have a comment here. Thank you, Nima, for sending your comment. And especially thank you, Nava, for spending some minutes with us during maybe your lunch break. It was a very informative and insightful exchange.
Thank you, Daniel, and thank you, Nima, as well. And I look forward to seeing everyone in person in Berlin. I'm very excited every time I give a talk in person, and it's basically, I think, five every online session I have in person. I remember how much, so much better, it's to do in person talks, to see the reactions of the people in the audience, to meet afterwards. So if somebody raises their hands, it's not the same. The networking, the food,
Yes.
it's just a completely different experience. So I'm really looking forward, and of course to see Berlin. It's always nice to see Berlin.
Yes, great. I'm also very much looking forward to meeting in person and to enjoying the time together.
Okay, thank you everyone. Bye.
Bye.